Let's dive straight into the core of Python programming, its fundamental functions. These aren't just any functions, they are the essential building blocks that underpin virtually every Python program you'll encounter or create. Think of them as the alphabet and basic grammar of Python. Without mastering them, you're limited in what you can express. We're talking about a versatile toolkit that offers everything from simple data type manipulations to complex operations, making Python such a powerful language. Getting comfortable with these 50 functions is non-negotiable if you want to write efficient, readable, and effective Python code. First up, let's talk about data types and how we handle them. The type function is your diagnostic tool, instantly telling you what kind of object you're dealing with. Is it an integer, a string, a list? Type tells you. Then there's isInstance, which is more specific. It checks if an object is an instance of a particular class, or even a tuple of classes. This is crucial for robust type checking in your code. Of course, Python is dynamically typed, but knowing these types is key. And then comes the family of conversion functions: int, float, str. These are workhorses for converting between numerical types and strings, something you do constantly. Bool converts values to true or false, which is fundamental for control flow. For more specialized needs, complex creates complex numbers, and for handling binary data, bytes and byte array give you immutable and mutable byte sequences respectively. Finally, memory view allows for efficient access to the internal data of an object without copying, which is great for performance in certain scenarios. Mastering these helps you manage data effectively. Now, let's move on to how Python interacts with the outside world: input and output. The input function is straightforward. It reads a line from standard input, typically waiting for the user to type something and press enter. It's the primary way to get user input in simple scripts. On the flip side, print is how you send information out, displaying text to the console. While simple, it's incredibly versatile with formatting options. For working with files, the open function is your gateway. It takes a file name and a mode like re for read, we for write, a for append, and returns a file object. This object is then used to interact with the file. Underlying much of this, I/O, are the sys module standard streams: sys, stdin, sys, stdout, and sys, stir. These represent the standard input, output, and error streams respectively. Understanding these gives you finer control over where your program reads from and writes to, especially important when redirecting output or handling errors programmatically. Strings are arguably one of the most used data types in Python, so knowing how to manipulate them is vital. Len gives you the length a quick check. Star converts things to strings, as we saw. Repr aims for a more unambiguous representation, often useful for debugging. Format is incredibly powerful for creating formatted strings, allowing you to insert variables and control alignment, padding, etc. Think formatted strings, literals, f-strings, but programmatically. When you need to break down a string, split does the job, splitting on whitespace by default or any specified separator. Conversely, join combines a list of strings into one. Cleaning up strings, strip removes leading and trailing whitespace. Need to replace parts of a string? Replace handles that. Looking for substrings? Find and index locate them, with index raising a value error if not found, unlike find, which returns -1. And for case manipulation, lower and upper are self-explanatory, but essential for case-insensitive comparisons or transformations. These functions make string processing in Python remarkably efficient. Lists are the go-to ordered mutable collection in Python. The list function itself creates a new list, often from an iterable. Len tells you how many items are in it. Adding items is common. Append puts one element at the end, while extend adds all elements from another iterable. If you need to place an item at a specific position, insert is your tool. Removing elements can be done via remove, which deletes the first occurrence of a value, or pop, which removes and returns the last element, or an element at a given index. Clear empties the list entirely, and copy makes a shallow copy, useful for creating independent lists. Count tells you how many times a value appears, and index finds its position. Modifying the list structure includes reverse, which flips the order in place, and sort, which sorts the elements according to the default comparison or a custom key. These methods provide comprehensive control over list data. Dictionaries are Python's implementation of hash maps, perfect for key value storage. Dict creates a dictionary. Len gives the number of pairs. Accessing keys, values, or pairs is done via keys, values, and items, which return views, meaning they reflect changes in the original dict. The get method is super handy for fetching values associated with a key, but instead of raising a key error if the key doesn't exist, it returns a specified default value, often none or an empty string. Popatem removes and returns a random key value pair, useful for implementing caches or algorithms. Pop specifically targets a key, removing it and returning its value. setDefault tries to get the value for a key. If it doesn't exist, it sets the key to a default value and returns that default. Update merges another dictionary's key value pairs into the current one, overwriting existing keys. These methods make dictionary manipulation both powerful and safe. Sets are collections of unique unordered elements. Set creates a set. Len gives the count. Adding elements is done with add. Removing elements has two main methods: remove, which throws a key error if the element isn't present, and discard, which silently ignores the request if the element isn't there, making discard safer for uncertain removals. Pop removes and returns an arbitrary element. Clear empties the set, and copy makes a shallow copy. Sets truly shine with their mathematical set operations. A subset and a superset check relationships. Union combines elements from two sets. Intersection finds common elements. Difference finds elements in one set but not the other. And symmetric difference finds elements in either set but not in both. These operations are incredibly efficient for tasks like deduplication, membership testing, and set algebra. Functions are the cornerstone of modular programming. Def is the keyword used to define a function, specifying its name, parameters, and the block of code it executes. Return exits the function, optionally passing back a value. For simple, throwaway functions, Lambda creates small anonymous functions, often used for short operations, especially within functions like map or sorted. To introspect the runtime environment, globals and locals return dictionaries representing the current global and local symbol tables, respectively, showing available names and their values. Eval takes a string and evaluates it as Python expression, which can be powerful but risky if used carelessly with untrusted input. Exec executes a block of Python code provided as a string, useful for dynamic code generation or execution. Be cautious with eval and exec due to potential security implications and reduced readability. Control flow is how we dictate the order of execution. The for loop iterates over any iterable, like lists, strings, or ranges. While loops continue executing as long as a condition remains true. Conditional logic is handled by if, elif, and else. Break immediately terminates the innermost loop. Continue skips the rest of the current iteration and moves to the next one. Pass is a null operation, often used as a placeholder where syntax requires a statement but no action is needed yet. Range generates sequences of integers, commonly used in for loops. Enumerate adds a counter to an iterable, making it easy to track indices. Zip takes multiple iterables and aggregates their elements into tuples, ideal for parallel iteration. Reversed iterates over a sequence backwards, and sorted returns a new list containing all items from the iterable in ascending order. These tools give you precise control over how your code executes. Error handling is critical for writing robust applications. The try block encloses code that might raise an exception. Except catches exceptions. You can specify the exact exception type, like file not found error or value error, or use a general exception. An else block, if present, executes only if the try block completes without any exceptions. Finally is guaranteed to execute, regardless of whether an exception occurred or not, making it perfect for cleanup actions like closing files or releasing resources. Raise lets you manually trigger an exception. Assert is a quick way to validate assumptions during development. If the condition is false, it raises an assertion error. Proper exception handling prevents crashes and makes your programs more resilient. We touched on open earlier, but let's look closer at file operations. Once you have a file object from open, you can read its contents using read, which gets everything at once, read line for a single line, or read lines to get all lines into a list. Writing involves write, which takes a string, and write lines, which takes a list of strings. Crucially, after you're done with a file, you must call close to release the resource and ensure all data is flushed. However, the preferred modern approach uses the with statement as a context manager. Opening a file with closing with automatically handles the closing for you, even if errors occur inside the block. This is cleaner and safer than manually calling close. Modes like ru, 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 ru determine how the file is opened for reading, writing, appending, or binary mode. Interacting with the operating system and Python's environment is sometimes necessary. Sys. argv provides access to command line arguments passed when running a script. Syspath lists directories where Python looks for modules. Isplatform gives a string identifier for the underlying platform. The os module offers more os-specific functions. Os name gives the os name. Os getCTD tells you the current working directory. Os changes it. And os listdir lists the files and directories in a specified path. Os system can execute a command in the shell, though subprocess is generally preferred for more complex interactions. Platform provides detailed information about the hardware, OS, and interpreter. These functions allow your Python code to be aware of and interact with its surroundings. Finally, let's round out with some miscellaneous but incredibly useful functions. Help is your interactive documentation browser. Type help in the REPL to see it in action. Dir shows the attributes and methods of an object. Great for exploration. It gives the unique integer identifier of an object, useful for understanding object identity. Hash returns the hash value, important for dictionary keys and sets. Basic math functions like abs, round, pow, min, max, sum, and all any are built in. For iteration, we've seen enumerate, reversed, and sorted. Filter applies a function to each item and keeps those for which the function returns true. Map applies a function to each item and returns a map object. These functions, combined with the others, form a powerful and expressive toolkit for Python programming. So, that wraps up our overview of these 50 foundational Python functions. As you can see, they cover a vast range of common programming tasks. Mastering these isn't just about knowing the syntax, it's about developing an intuitive understanding of how Python works under the hood. This foundation is absolutely critical for moving beyond basic scripting and into building sophisticated, high-performance applications. Familiarity with these functions directly translates to writing code that is not only functional but also efficient, readable, and maintainable. They empower you to solve problems elegantly and effectively, leveraging Python's strengths. Keep practicing these and they'll become second nature.